Here's a problem I'm going to do for this video. And this time, if you look at it, there is some very distinct tells for what this problem type is. And Ms. Knudsen emphasized this greatly the last time we talked about it together. Look at all these crazy charges. Look at this KSP. This is your dissolving problem. This is your KSP problem. This is the problem that a lot of people did not spend enough time trying to learn. And it is the easiest of the four. Okay, that might be a lie, but it's very easy. Okay, if I give you anything that looks like dissolving in KSP, you will need a Rice table. There's only one problem you do not need a Rice table, and that's when I say, here are all your numbers at equilibrium, you morons, right? So this one, I don't give you numbers at equilibrium, I give you KSPs. You got to figure stuff out. So 2.85 was placed in water, so that was my initial amount, which means there aren't any of these. Your change is always minus for your numbers, plus for your zeros, and then their x's. Coefficient, coefficient. Miss Lee gave you a crazy coefficient because life is more fun that way. Equilibrium is always the initial, plus or minus the change. I'm not going to write down the zeros because that would be extra. And there are my equilibrium numbers. I don't really have a lot of information in this problem. Okay, but the question asks, what is the concentration of the dissolved ions? This is just like the other KEQ problem where it asks for what's the concentration. Okay, when I'm asking you for the end up information about concentration, I'm asking you for E. E is the concentration at equilibrium. If you're like, what the heck is it referring to in relation to dissolved ions? Ion means charged. AQ means dissolved. So the final answer for this problem will be the concentration of the M ion and the concentration of that hydroxide ion. Concentrations also are labeled in molarity. So if you don't come up with a big M in the end, you did something wrong. Remember that your K expression is always your K equaling the concentrations of the reactant raised to a power of the coefficient. So M does not have a coefficient, but hydroxide does. So we're going to raise it to the fifth. And there's nothing in the denominator because my thing I'm putting in is a solid. So that's my K. Is it? This is why this problem is easy. They look this way every time. Okay, I have my ice table. I have my KSP. In my KSP, I will not use the solid. So while that information could be useful sometimes, in this problem it's not. I give you a KSP, and that KSP equals the equilibrium concentrations. Well, in my ice table, I found the concentration of M is defined as X, and the concentration of OH is defined as 5X. Do not forget to raise that to the fifth because that power is there as part of the equation. Okay, so 5 to the fifth, right, is 25. Oh, I'm wrong. Oh my gosh, is 5 to the fifth a crazy number? Whoa. Guys, 5 to the fifth is a crazy number. Who knew? 3, 1, 2, 5. And then you also have to bring the x to the fifth. That's still multiplied by x. So the last step is to take that x to the fifth multiplied by x, which means it's x to the sixth. That number still equals my KSP, which I give you. Okay. And now we're just trying to solve for x, just like we did on my non-KSP problem, so that I can come back up to this row to get the information to solve this question. So I'm going to divide both sides by that 3125. Put it in my calculator, maybe right. Oh man. Okay. Calculators and I are friends. We all know that. Oh geez, that is a very small number. So x equals 1.38 times 10 to the negative 12. Remember that E is just times 10 to the. So to answer the question, the concentration of the M is just X. So concentration of M is going to equal the X I just calculated times 10 to the negative 12. Label of big M, because that's how you label concentrations. And the concentration of hydroxide is just that X times 5, because that's how we defined the concentration of hydroxide. Okay. So when given a KSP problem like this, we do our ICE table, we plug into the K, solve for X, plug it back, and get your final answers. Huge on the test. People forgot these labels left, right, and center. If I'm asking you about concentration, please put a big M on it. The only number in this unit that does not have a label on it is K, and K is labelless. That's it.